So another non-math section, right? We're going to talk about deductive reasoning. Inductive reasoning is where you're making hypotheses or conjecture about a pattern. Deductive is based on fact. That's kind of the difference between inductive reasoning and deductive reasoning. So in deductive reasoning, if I say, if it's raining outside, then I'm going to bring an umbrella, and you take that as fact, and then I tell you it's raining outside, what can you conclude? I'm going to bring an umbrella. Okay? So we're dealing still with having to identify what a hypothesis and a conclusion is in a statement, but now we're going to work with the fact that the statements that we're given are either going to be, if they tell us that that statement is true no matter what, then we assume it's true, and then all of our answers are based on that statement being true. Okay? There are statements that you're going to have to identify whether they're true or false. If an angle is supplementary, then it's equal to 60 degrees. Well, it could be true, but it may not be true. So that's not going to be a fact. So there's going to be times where you're going to have to identify whether it's truly true or false, or if they give it to you to be true, then you have to assume if they give you the hypothesis, then the conclusion would follow. Okay? With this section, there's 3 laws that you must know. One is called the law of detachment, one's called the law of syllogism, and one's called the law of contrapositive. Okay? And when you're dealing with these laws, for me, I think it's easiest to write them with the P's and Q's. So if we go ahead and use the one I said, if it's raining, then I'll bring an umbrella. I'm just going to shorten it. Okay, so what's P here? Just it's raining, right? No if. It's whatever follows the if. It's raining. P. So I'm going to call this P, and then I'm going to call this Q. So I could write this as if P, then Q. Everybody with me? The law of detachment says if I'm given a statement like this, P then Q, and then they tell me that P happens, I can then conclude, which is what these 3 dots means, therefore. Those are the 3 dots. They mean therefore. If P then Q, if it's raining, then I'll bring an umbrella. It's raining, I'm given that. I conclude, or therefore, I'll bring an umbrella, which is actually Q. That's the easiest law, the law of detachment. Okay, now don't get confused with this. If I tell you if P then Q, if it's raining, then I'll bring an umbrella, and then I tell you I'm bringing an umbrella, can you conclude it's raining? It only works if I'm given the hypothesis as fact. If it's raining, then I'll bring an umbrella. What do you know? It's raining. Then I'll bring an umbrella. I can't say if it's raining, then I'll bring an umbrella. I brought an umbrella, therefore it's raining. That's not the law of detachment. With the law of detachment, you have to be given the hypothesis as fact, not the conclusion. Everybody understand the difference? Because these get confusing, and I want to make sure you're all following me. Okay? If I eat 10 peanut butter and jellies, then I'm going to get a stomach ache. I have a stomach ache. What can you conclude? No, I can't conclude that. That's the point. If I say, if I ate 10 peanut butter and jellies, then I get a stomach ache, and I tell you I ate 10 peanut butter and jellies, you can conclude then I get a stomach ache. But if I tell you I have a stomach ache, it could have been something else. I could have had the flu. I can find a counterexample that would disprove that logic. Okay? Law of detachment, you're given a conditional, if P, then Q, and then you're given P. P happens. You can then conclude Q will happen. That's the law of detachment. Okay? The second law is the law of contrapositive. Who remembers what a contrapositive is? You had to know inverse, converse, contrapositive. What's a contrapositive? Those who are planning to retake 2.1 and 2.2, this might be a good review. What do? If I'm giving you a conditional, how do I find the contrapositive in terms of P and Q? What do? Switch them and make them both negative. Okay, so the contrapositive, not Q and not P. So let's play this one. If it's raining, then I'll bring an umbrella. What's the contrapositive tell me? Yes, and that will be true. The original statement and the contrapositive will always be true together or false together. If the original statement's true, contrapositive will always be true. If the original is false, the contrapositive will be false. That's just the rules of logic. Okay? So if it's raining, I'll bring an umbrella. If I didn't bring an umbrella, then it's not raining. That's the law of contrapositive. And the last law with these is the law of syllogism. And the best way to remember, who remembers the transitive property? You have commutative and you have associative. There's one called the transitive. Anybody remember it? Transitive property says if A equals B, B equals C, then A is C. That's the transitive property. And there's got to be two conditionals for the transitive property to work here. This is called the law of syllogism. Law of syllogism, transitive property mean the same thing. Okay? Law of syllogism works this way. I have to have two conditionals. Here's one. If it's raining, then I'll bring an umbrella. I need to have another one that says, if I bring an umbrella, I'm going to make something up. Then I'm late to work. I just made it up. The law of syllogism, in order for you to use it, the conclusion of the first conditional must be the hypothesis of the second. The conclusion of the first must be the hypothesis of the second. And the way it works, if that's true, now I can say, if it's raining, then I'm late to work. Because it went, if it's raining, I bring an umbrella. If I bring an umbrella, I'm late to work. Therefore, if it's raining, I'm late to work. But it only works if the conclusion of the first is the same as the hypothesis of the second. And they basically cancel each other out, and you end up with the hypothesis of the first, conclusion of the second. Okay, that's the law of syllogism. On your big ideas, you're going to have to tell, when they give you some conditionals, whether they're using the law of syllogism or law of detachment. Okay. The other thing that's going to be important in this section is understanding something called truth tables. And in order to understand truth tables, you're going to need to know what some symbols mean. Anybody know what those mean from the reading? Because you all read your stuff, right? So you guys should know what these symbols mean. What are they?
First one's not.
Okay. And the second one, good. First one's and. The other one's or. The way I remember them is that first symbol looks like the beginning of an A. And starts with A. That's how I remember it. So this is and because this one's an upside down A, it's not an A, so it's or. Okay? So we're going to be working on something called truth tables. If I want to represent P and Q with a truth table, to True, false is what I want to do. No, I want to do it here. True, false, true, false. I can't remember in the book if they do true, false first. I think they do. You want to do it the right way every time so that it's consistent. So this is saying P is true. This is saying Q is true. This is saying P is true, Q is false. P is false, Q is true. P is false, Q is false. Okay? When you're dealing with AND, for P and Q to be true, both P and Q must be true. If they aren't both true, then the whole thing is false. So the only time an AND is true is in this scenario. Every other time, ANDs are false. So this is the truth table for P and Q. Okay, anytime you just have two letters, you're always going to go true, false, true, false to start out. This is the way you'll always start them. And then you're going to determine what this one is based on this symbol. So if I wanted to go P or Q, well, with ORs, if I said go to the store or take a nap, I can do either one, and it's still part of what I was asked to do, right? So for an OR to be true, either one is true, the OR is true. Okay, so here, they're both true, so this is still true. Here, P is true, Q is false. Because one of them is true, the statement or P or Q is true. Here it's true. The only time an OR statement is false is when they're both false. And if this is the first time you're seeing it, that means you didn't read or watch the video. I would encourage you to do that, because you're going to need to know how to build these truth tables on a quiz. Okay, on Big Ideas, they also have some truth tables. And their truth tables are truth tables for if P then Q, not and or. Okay, so if I do this, and I still have my P and Q, and I still have my true, false, true, false, false, true, false, true, false, and I want to do P then Q, think about this. Is it possible for me to have a conditional statement that I give you that P is true, then Q happens? That would be a true conditional statement. I could also give you one that says, like I did, if two angles add up to 180, then they're complementary. Is that a true conditional false result? If two angles add up to 180, they're complementary. Is that true? No. So that would be a true with a false result. Here, I could say, if it's raining, then I bring an umbrella, but it's not raining. I could still bring an umbrella. And then false, false. So the only one that you can't do with a conditional, if we know everything's true, this is the only one that will be false. These can both happen, because if the conditional is not met, then the result doesn't matter. Okay, so this is what a truth table looks like for a conditional statement, if P then Q. True, false, true, true. Okay, you're going to have to do truth tables on Big Ideas with conditional statements. Okay, A lot of information in this section. A lot of it doesn't seem like it pertains to math, but with logic, which is what this is, you've got to be able to train your brain to think logically in order to do proofs in geometry, and that's what we're leading up to. So we're just trying to work on logic and having you think through things. Okay? All right, get to work.